So next up, we're going to be doing that example in a spreadsheet, but I thought it would be good to practice the setup for one of these by hand problems just one more time so that you can for sure see what's going on. This is going back to, oh, I've even written it down wrong. Okay, this is going back to the logistic equation that we were working with when we learned about equilibrium values last week. And it's dn dt is r times n times k minus n. So I picked 0.4 for r and 0.5 for k. And given initial condition n of 0 equals 0.1, told to use h equal to 1 to find n of 3. And so I'm going to do this thing again where we kind of connect the example back to the notation that we've been using. So first off, we've changed what we were calling x before, we're calling t. So our independent variable, the thing on the bottom of the derivatives, is t now. And what we were calling y before, our dependent variable, is n. So the thing that we were calling f of xy, that's the derivative, the thing on the right-hand side of the equation, dy dx equal to blah, is dn dt equal to 0.4n times 0.5 minus n. And the thing that we were calling x0, y0 is just going to be 0 for x and 0.1 for y, or in the notation of our problem, 0 for t and 0.1 for n. We use h equals 1 and stop at x equals 3. And you can make your own choice about this, but when I do the Euler's method, I'm going to go ahead and keep the x's and y's just because that's what you're used to seeing. But we're going to know that the y value is our n that we're actually trying to find. So what I'm going to do here is I'm going to do that tip that I gave you for making sure that you include all the x values by just computing them all to start. So we started x0 equals 0, and then we know that x1 would be x0 plus h, so that's 0 plus 1. We know that, I guess that's 1. X2 would be x1 plus h, so that's 1 plus 1 is 2. We know that x3 would be x2 plus h. So that's just 2 plus 1 is 3. And that's where we're going to stop. We want to find n of 3. So once we've reached x3, we'll be at y3. That's going to be the value we want. And then we start at y0 being 0.1. And we know that y1 is going to be that y0 plus h times f of x0, y0. So our y0 is 0.1, our h is 1, and our f is this thing right here. So we're going to just plug in everywhere we see n, our current inputs, x0, y0, which unfortunately for this problem doesn't actually involve the x value, but that's okay. So it's 0.4 times 0.1 times 0.5 minus 0.1. And I can do that real quick on a calculator, well, on my phone actually, because I don't have a calculator. So that's 0.1 plus 1 times 0.4 times 0.1 times 0.4. I've got 0.116. Then y2 would be y1 plus h times f of x1, y1. So we would plug in this value, 0.116. Our h is still 1. And our f is going to be using the same formula as before, but now we plug in our most recent values. So that's going to be 0.4 times 0.116 times 0.5 minus 0.116. So I'll go ahead and give that number, but I'm just going to kind of draw a squiggle for y3 because this is already getting kind of ridiculous. So 0.116 plus 1 times 0.4 times 0.116 times 0.5 minus 0.116 is 0.1338176. And then I'm just going to write the formula for y3 because it's good practice, but we are not going to compute it. Y3 is going to be y2 plus hf of x2 y2. So that's going to be 0.1338176 plus 1 times 0.4 times 0.1338176 times 0.5 minus 0.1338176, which is definitely a number. And that would be our answer. I'll put a star there because I erased all the other stars. So you'll know that that star means there's an answer that I didn't feel like solving. And that's how this type of problem works when you do it with pen and paper. But hopefully you've noticed that this is kind of tedious. That's not how you spell kind. So doing these problems by hand a couple times will ensure that you understand the process. But doing them on a computer is faster. That's not too bad. So that's why we're going to do this little spreadsheet exercise in the next video. So I'm going to end here, and the next video you'll be looking at kind of a spreadsheet example.